Hello, ladies and gentlemen. So today we are reviewing factoring, and it's back and it's bigger than ever. You have some notes here that we should be referring to as we review our factoring. Remember this little foldable guy we made earlier? We talked about factoring and how all the different methods we use to factor. All of these are coming back now as we factor things with higher exponents or polynomials that have higher degrees. So all of these same methods are still going to work for us. It's just they're going to lead us basically through larger steps or more, yeah, I guess basically more steps to our problem as we go ahead and start factoring them, okay? So remember, to factor means to break apart into little parts that are being multiplied. And the strategy is the same, but the answers in the problems look a little different now that we have those higher orders. So let's go ahead and take a look at or review greatest common factoring. So greatest common factoring is looking for a common thing or term that you can divide out of everybody. So looking for a common number you can divide out or a common variable that you can divide out. The reason we look for GCF first is because we always want to make sure that we're breaking apart things the easiest way possible, and greatest common factor helps us start that process. So what number can I divide out of both 50 and 25? I can divide them both by the number 25. And now take a look. Both of these have x's in them. One has an x to the fourth and one has an x squared. That means I can divide at least an x squared from both pieces. So once I decide what my greatest common factor is, the 25x squared, I now literally divide him out of both of those terms. So 50 divided by 25 is 2, and an x to the fourth divided an x squared out is x squared. And then negative 25 divided by 25 is negative 1. X squared, divide out the x squared, he doesn't have any x's left. So this has been factored using greatest common factor. We place what it is we're dividing out here, and then this is what the polynomial looks like once we divide it out. So now let's take a look at group factoring again. This is what we do when we have 4 terms. Group factoring requires us to look at the first 2 terms and the second 2 terms as two separate groups. So if I go ahead and look at these 2 terms, what can I divide out of both of a 30 and an 18? I can divide them both by the number 6. And because this has an x to the third while this one has an x squared, I can divide them both by x squared. So this first term, if I divide out 6, becomes 5 and an x, because x to the third divide an x out leaves me with 1, or divide x squared out leaves me with an x. Negative 18 divided by 6, negative 3. Nice, and that x squared, he doesn't have any more x's because I've divided them out. Now look at these last 2 pieces. What number can I divide out of both 25 and 15? I can divide them both by the number 5, but because this lead coefficient here is negative, we'd want to go ahead and divide a negative 5 out, making my x coefficient positive here. So negative 25 divided by negative 5 is positive 5x. 15 divided by negative 5 is negative 3. Now notice how my 2 repeating factors are here, 5x minus 3. They're both the same. That's good. That means we're factoring correctly. And then what I took out is 6x squared minus 5. These are my 2 factors that were multiplied to make this polynomial to start. So we're trying to factor these things apart using our strategies. Now let's take a look at this one. Ooh, this is kind of weird. I wonder how that happened. There we go. Let's go ahead and take a look at this one. And we have 3 terms. We have a 2x squared minus a 5x minus a 12. So we can go ahead now and do the AC method for these. So to do that, we take a times c, 2 times negative 12, negative 24. What multiplies to make negative 24 and adds to make negative 5? Negative 8 and 3. So I'll rewrite this problem as 2x squared minus 8x plus 3x minus 12. And I'll group again. What can I divide out of those two? 2x, leaving me with x minus 4. What can I divide out of these two? 3, leaving me with x minus 4. So my 2 factors are 2x plus 3 and x minus 4. Okay, trinomial factoring, what you do when you have 3 terms. Now let's take a look at another trinomial factoring, but those exponents just got a little bigger, so the way we approach this one might change a little bit to start. Notice that I have a 4x to the 6th minus a 20x to the 4th plus 24x squared. What I'm noticing right away is that's a lot of x's. In fact, everybody's got some, so that means that I should look to do a GCF first. How many x's can I divide out of each of these terms to start? I can factor out at least an x squared from each of those terms. And because 4, 20, and 24 are all divisible by the number 4, I'm going to divide that out as well as my greatest common factor. So when I divide 4x squared out from each of these terms, I get an x to the fourth minus a 5x squared and then plus 6. Okay, check that out. We're dividing a 4 and an x squared out of each term. Now what I have done is just greatest common factoring. I just took out that 4x squared, but I have not finished factoring. In fact, I still have a trinomial here that can be factored some more. It has 3 terms inside the parentheses, so I need to look to do the AC method again. The AC method is look in the number in front, the lead coefficient here is 1, and the back 6, and I ask myself what multiplies to make 1 times 6. That's 6. What multiplies to make 6? 6 and 1, 2 and 3, negative 6 and negative 1, negative 2 and negative 3. These are all ways I multiply to make positive 6. I'm looking for the partnership or the pair that adds to make negative 5. That would be these guys, okay? So I'm going to rewrite x to the fourth minus 2x squared. Why am I putting an x squared there? Because the middle term had an x squared, ladies and gentlemen. Negative 3x squared and then plus 6. So I've taken the 3-term problem and turned it into 4 so that I can group once more. What can I divide out of each of these? An x squared, leaving me with x squared minus 2. What can I divide out of each of these? Negative 3, leaving me with x squared minus 2. So my two factors are x squared minus 3, and the other one is x squared minus 2. And then let's not forget about this little 4x squared that pops down because we took them out originally, and now we are in factored form, okay? So now let's look at one more type of factoring we talked about, and that's perfect squares. Understanding that you can look at things with 2 terms, and if those numbers are perfect squares, we can go straight from the problem into the parentheses. So I see 16 and I see 81 and I see those are perfect square numbers. So I ask myself, what 2 numbers multiply to make negative 81? One would be a negative 9, the other would be a positive 9. Because the 81 is in the back or the end of that expression, I would place them in the end of my parentheses. Now what about 16x to the fourth? 16 is the perfect square root that, 4, right? 4x, but that's more than just x, because x times x doesn't make x to the fourth. X squared, okay? This is nice, but it gets even better. Tell me about this set of parentheses. That is a difference of perfect squares as well. This one gets split apart one more time into 2x plus 3 and 2x minus 3. Check that out. We had 4x squared. Square root of 4 is 2 and 2. We have a negative 9, positive negative 3's. We can't do that with this guy because he's not a difference of perfect squares. There's no pattern to factoring a sum. That's what it means when you have a plus sign right there. A sum of perfect squares cannot be broken apart any further, whereas a difference can. All right, let's take a look at a few more examples here in your notes. We have x to the third minus x squared minus x minus a 1, or plus a 1. This is 4 terms, so let's group them. What can I take out of these 2 terms? X squared, leaving me with 1x minus 1. X squared divided by x squared is 1. What can I divide out of both of those terms? Maybe just a negative 1, since the expression starts negative there, leaving me with x minus 1. So I have x squared minus 1, the stuff I took out, and x minus 1, the repeating factor. Now, ladies and gentlemen, check out this x squared minus 1. He's a perfect square. 1 is a perfect square number. We don't think about that often. That splits apart into x plus 1 and x minus 1 because the square root of 1 is still 1. This guy doesn't have a squared anymore, so I'm going to keep him as just x minus 1. Those are my 3 factors that come from this original expression. Okay, here's example 2. This one has 3 terms. Is there anything common I can divide out of each of those? Nope. So I'll do the AC method. 3 times 10 is 30. What multiplies to make positive 30? Oh, 5 and 6, 2 and 15, 1 and 30, all of those, but I need them to add to make negative 11. What if they're both negative in terms of negative 5 and negative 6? That would make negative 11, and it would multiply to make positive 30. So I'll rewrite this problem as 4 terms using the negative 5 and the negative 6x, still making 11x in the middle. And now I'll go ahead and group. What can I divide out of each of these? X, leaving me 3x minus 5. What can I divide out of each of these? 2. Negative 2, leaving me 3x. 10 divided by negative 2 is negative 5. So my factors are 3x minus 5, x minus 2. I know I'm done because I don't have any more squareds left in there. Nothing else could be broken apart here. I don't have any higher exponents that I should look to see if I need to break apart any further. Now let's look at a third example. This has 3 terms as well, but I'm seeing that they all can be divided by 2 and an x right away. Do you see that? They all have x's and they all have even numbers, so I can divide them all by 2 and x right away. And if I do that, divide this first term by 2 and an x, I'll get x squared. If I divide this by 2, I'll get negative 4x. And if I divide 8 by 2, I get 4, because that x is now being divided out by the greatest common factor here. So look what I have left. I have x squared minus 4x plus 4. Well, that's still a trinomial, and it still has a squared, so I need to do the AC method. What multiplies to make 4 and adds to make negative 4? Negative 2, negative 2. So I'd rewrite this guy as x squared minus 2x minus 2x plus 4. So I can group, take out an x minus 2, take out a negative 2, x minus 2 again. So my two factors are x minus 2 repeating stuff, right? And then the x minus 2 that I took out. And then don't forget that little 2x that we divided out right away at the beginning. So this is my factored form of that expression as it started. And example 4. This one also has 3 terms, but I'm noticing 18, negative 21, and 3. I can divide all of those by the number 3 first. They all divide by 3, so I'm going to take out that greatest common factor first, making this become 6x to the 4th minus 7x squared, and then plus 1 when I divide each term by 3. Now again, inside this set of parentheses, I still have a trinomial that has a power in here, x to the 4th, meaning I probably could split this guy apart some more. I need to do so by the AC method. One more time. 6 times 1. What multiplies to make 6 and adds to make negative 7? Negative 6, negative 1. So I'll rewrite this problem as 6x to the 4th minus 6x squared minus 1x squared plus 1. Notice that the middle terms are x squareds because our middle term above was an x squared. We still have to make sure they add to make negative 7x squared like the problem above says. Now once I've rewritten it with 4 terms, I group. What can I divide out of each of those? 6x squared, leaving me with x squared minus 1. What can I divide out of each of those? Probably a negative 1, leaving me with x squared minus 1. So I'll go ahead and write my factors. 6x squared minus 1, the stuff I took out here and here. And then the repeating factor is x squared minus 1, like so. Now I have him factored, but I'm still a little concerned because I have x squareds in my factors. So there's a possibility this could be split apart some more. Remember what we talked about with negative 1 here. He's actually a perfect square. So this x squared minus 1 can be split apart into x plus 1, x minus 1. This is a negative 1 here, so you're thinking maybe perfect square, but notice in front there's a 6. 6 is not a perfect square number. So that means because they are not perfect squares, we have to leave them as is. So this is the factored form of that original expression. Okay, so we are talking about factoring and always remembering our greatest common factoring first. Make sure that you take out a greatest common factor, then you do whatever it we have to do. If it's 4 terms, you group. If it's 3 terms, you do the trinomial method, AC method, and if it's 2 terms, look for that perfect square number, okay? So I want to thank you, ladies and gentlemen. Kincaid out.